To continue with the object context that we had been referring to, we have identified or we have understood that we can connect a data object to an interface object, and we can also access a data object through an interface object. Various ways that the data can be collected into a collection. A gathering of various objects, could be a TDL object, could be an internal object, could be a summary collection into a collection. Now there is, at certain point of time, you only need to switch the data context, or you only need to switch to an object context for retrieving a particular value, where you might have to move from the current context of your data or your interface to any other context. So to refer to various contexts of an object, we have functions. So we can categorize these functions into two categories: data object and interface object. So there is a set of functions which helps us to switch the data context, and there are a set of functions that helps us to switch between the interface objects. Data object context, we have owner, base owner, previous object, next object, first object, last object, TGT object, loop call obj, report object, request object, object of table, and table object. So starting with the owner object, basically this function evaluates the provided value or the method or the expression in the context of the parent data object. So say we are right now at a voucher object. A voucher object has inventory entries which has batch allocations. Now say we are currently at batch allocations. We require a value from the parent, the inventory entries. So we can say $owner, $stock item name. So this will fetch from the value from the inventory entries. Now if I say $owner, $owner, $amount, the amount will be fetched from the voucher object, because from the batch allocations, $owner is the inventory entries, and from inventory entries, $owner is the voucher object. Now if we want to get a value directly from the parent owner, the primary object of the current object, we can make use of a function called $base owner. So base owner evaluates the given expression in the context of the current object's primary object. So whatever is in the chain of the hierarchy, whichever is the primary data object, the value gets evaluated based on that within the report object. So the current data object context for the bill allocation remark field is bill allocation, and when we give $base owner $narration, it travels to the voucher object and fetches the value. Then we have prev object, next object, first object, and last object. Basically these are evaluated in the context of the previous object, last object, next object, first object, based on what is provided in the collection. So evaluates the given expression in the context of previous, next, first, and last data object of the collection, which contains the current object in the context, current data object in the context. So it's an assumption that the line is being repeated over ledger collection, where we require the first object name to be set. So only when you want the first object name, I say $first obj : $name. So as per my collection of ledger, whichever is the first ledger name is what will get retrieved in this first name field. Similarly, if we give $next object, it will bring us the next object value. Similarly, if we give the first object, it gives the first object value. We can give the last object, it gives the last object value. So these are very similar kind or similar lines. Then we have a function called TGT object. Now this function has a very peculiar behavior. This function evaluates the expression in the context of the targeted object, an object which is supposed to be your target. This is specifically used in user-defined functions or the aggregation collections. So listen to an example. There is a party 1 and there is a party 2. Both have some opening balance. The requirement is to add the opening balance of both the ledgers and get the resultant value of the opening balance of the party 2. So what we have done is, when we say new object party 2 and when I say $opening balance, this retrieves my opening balance from my party 1, and TGT opening balance, this gets the opening balance from party 2. Well, we'll be doing, there is another specific topic on user defined functions in which you will understand the exact structure of a function. So currently when I say $opening balance, my current data context is party 1, so this $opening balance retrieves value from party 1. $TGT object colon $opening balance fetches value from party 2, which gets added and gets set in my opening balance. This value gets set for my party 2. Then we have the report object. This function helps to evaluate the given expression in the context of the data objects associated at the report interface object. So say at report level you have mentioned object colon ledger. So whatever expression you provide at this function will get evaluated on ledger. So if you have changed that to object colon stock item, the expression will get evaluated on the stock item. So this is an example here. From a bill allocation data object context, voucher number of report object voucher is required. So at somewhere down the field we give $report object colon $voucher number. This is a default value that gets set here, right? Then we have loop call obj. This is a very specific function utilized for loop collections. So any kind of value that you need to fetch from your loop collection to your data collection or your resultant collection or your summary resultant collection is where the loop collection object function comes into picture. When basically a data collection is looped over a loop collection. Now any value that you now call will always be called from a data collection. You say $name, it will be called from the data collection. So in case you need a value from your loop collection is where $loop call obj function comes into picture. So this is how a consolidated list of vouchers across all the loaded companies will look like. And to get the company name, $loop call obj function is being used. So this $name comes from company collection. Then we have a function called rec object. This function evaluates the given expression in the context of the data object associated with interface object. What happens is there is a value that you need to fetch, but based on the interface it is associated to. So let's take an example we have here. A report is required to display ledger-wise sales totals. You see here we have a field where we are trying to fetch the value. The collection that assumed is that the line that is this field is available is repeated on a collection called collection ledger. We want the total of all the sales totals. So that sale total value of a ledger will be retrieved from voucher, which is of type sales. So we create a collection which is of types voucher, and we filter for sales vouchers. Now we will compute the required method here with the help of a function called $filter ANT total ledger vouchers. Now we require only those vouchers which belong to this party. So at this system formulae, I say $party ledger name. This $party ledger name refers to ledger vouchers, which is equal to the name that I would get in my collection ledger. So if we directly write a dollar name here, it will try to refer to the method value in my voucher object. So I say $request object, REQ object. So my requester object is my ledger object, and my current object is voucher. Talking about object of, this is related to the access name that we have. So object of is used to evaluate the expression in the context of data object associated with the interface object, which is specified or identified by the access name. This is specifically only for those definitions which are identified by access name. Syntax is object of, definition type, access formula, evaluation formula. The part custom association is associated with the ledger object customer. It is identified by the access name cust ledger. So this is an assumption that we have already made. The part, there is a part definition which is by the name cust object association with a ledger object customer. So there is an object called ledger, and the name of and it is related to to the ledger customer, and it is identified by the access name cust ledger here. So line object EX, ledger object associated to customer, access name is cust ledge. Now I want to retrieve the value based on the access name available here on this field. So we can say $object of, definition type part, access name cust ledger. What you want to retrieve? The parent. So to retrieve the parent. Table function, we have made use of a table very frequently in our fields, haven't we? Right? So this particular function specifically, this function evaluates the expression in the context of the table object which is selected in the field. So in the case where no object is available, the table expression evaluation fails and it returns a blank string. So we have already seen these functions, right? $table. So in field 1 we have the table. Field 2 we would like to call a value referred from the table only. So we make use of $table, the field name where the table is available, and the value that we need. So this is a simple example. $table, ledger name, the field name, and $parent. So whatever ledger I select here, its parent will get automatically selected here. There is another function called table obj. There's a function called table, and now we have a function called table obj. How are this different from each other? Well, even this function evaluates the expression in the context of the table object which is selected within the given field. However, in case where the evaluation of the provided expression fails, this particular function returns a logical result, that is a true or a false. It does not return an empty value. We have used it at multiple places where we can also validate, check whether the value selected at a particular field, is it a track? If it is a track, then return the order number. If it is empty, then return not applicable. If it is this, skip, else return the value. So basically table obj returns a value, at least a value called false, whereas the table returns a blank expression. Now we have the object context switching functions for interfaces. Interface object context switching using functions. So whatever functions we have currently discussed will directly correlate my value evaluation to the data context available within the interface. These set of functions will help us to move forth and back within the interface and fetch the values. So we have $access obj, $asRic obj, $ric owner, explode owner, brief line, and brief FRD. Now specifically with the function access obj, this changes the object interface object context to the one which is identified by the access name to evaluate the expression. So this is specifically will help us to change the current context only for the interface where the access name is specified. Here, $access obj, the line, the access name, and the evaluation value or the format. Then we have asRic obj. It is used to save the interface context to the current object for the evaluation expression. When we had specified the ric obj function, it changed it to the data context. This particular function helps us to save the requester context for the current object, and then the expressions are evaluated. This is a simple example of both of these functions. So we have a table of company vehicles in my field 1. It exists in the object context of voucher object. This is just an assumption. Assuming that this field is in the context of object voucher, the table we are calling is available in the company object under the sub object company vehicles. Now what we would like to do is we want to filter based on the unused vehicles. So we want only those list of vehicles which are not used in my sales voucher. So that's the criteria. We have a table. We want to bring it into this voucher object. Based on the vouchers that already exist, we want to filter up all those vouchers. So there is one filter criteria that we have already provided for sales vouchers. Now to this particular unused vehicle as request object, so connect me to my interface object. So my interface object is voucher. where is the request coming from? The field as requested object, that is the voucher object. Now filter count the collection name, used vehicle is my formula. In this formula, request object. Now what is my requested object? Voucher object is equal to $VCH vehicle. Now this VCH vehicle will be looked upon this collection. If you wouldn't have mentioned it here, it would have started looking here. So the requested object vehicle number is from my requested object is vehicles, and VCH vehicle will be from my pre-sales VCH because of the context. And then this is linked as rec object, it is linked to my interface. So collection CMP vehicles contains a list of vehicle numbers which needs to be compared with the voucher object. The function REQ object gets evaluated in the context of the object voucher because that's my requester voucher object, which is not expected to make the current collection as its requester. So for function, this request object is used because that is the context we want to use further into my current filtration. REQ owner evaluates the given expression in the context of interface objects owner in the current interface object hierarchy. So as per the interface hierarchy, we will have say menu. Menu is having a report, form, part, line and field. This is the hierarchy of the interface. So for instance, report is an, you can take an example like line is an owner of field, report is an owner of form. So if any object needs to get evaluated based on the requested owner as per the interface hierarchy, this function can be used. So say for example, report ICCF request owner variable is specified, set as $function return rec owner, and here it will be this what we specify, it will bring us the value return rec owner. So who is the owner of this function? Report. So the if you simply give the variable value, it will return Madhava. In case you provide the function, it will return Keshava, right? Explode owner. Every line can contain exploded parts. Any value that you need from your in your exploded part from the parent line, you can go for $explode owner to evaluate it on that main line. So here is an example that we have done. $explode owner hash the name field, it gets the value from here. If we would have mentioned simply hash name field, it would have returned value from here. Prev line, this specifically returns a value from the previous line, and it is used to change the requested to the previous line for the expression. Here it is not the object, the line object, it is the line that we are targeting for. So this is one simple example where we are trying to get subtotals and we are exploding to a part. We are validating whether the previous party name and the current party name are same or not. If they are not same, then only the part has to get exploded. So that's what we have tried to do. Pre-field, this function is used to extract the value of the field in the previous field. So as per the multi-column reports, we have previous field and the current field. So pre-field helps us to get a value from the previous field. Specifically when we have a periodicity in multi-columnar reports where we validate what was the last period or the date specified in my previous field. Based on that, you change the current field period date values. So this is where pre-field comes into picture, helps to validate the values from the previous field. Now there are specific functions used to operate on collections to retrieve certain values. So the set of functions are bifurcated as per the extractions or the filtration functions. For extractions we have full list EX, call AMT total, call QTY total, call num total. For filtration we have filter AMT total, filter QTY total, filter count and filter value. Specifically, full list returns the values of a collection in a comma separated values. So first method, first object and the second object come together but in a comma separated format. There is a little significant change between full list and full list EX. When you provide a full list function, it is separate. The separator is always a comma. However, with the full list EX, you can provide your separator, whatever your separator character is. So it is $full list EX colon the separator symbol that you need, colon your collection name, colon your method name. So that's how it works. Full list EX. Now coming to call AMT total. This particular function helps us to bring a summarized amount based on the collection specified. Again, it is specifically to sum the values of type amount. So the expression value that you provide has to be of type amount. Similarly, if you have quantity total, it has to be of type quantity. Please note that the totaling of the quantity can be done only if the unit of measures are same. And for numbers, we have call num total. So this function is used to get the values of the type number returned by the specified expressions. So which will be applied to all the objects of the collection, and the value that it will return will also be of type number. Then we have filter value. This function returns a value based on the position number specified and the condition specified. So the syntax goes as $filter value expression, collection name, position specifier and the filter expression. The filter expression will always be a system formula. The value expression can be any method name or any other expression which can be evaluated within the object that you have provided as your collection name, and the position specifier denotes the position. You want one, the first one, the second one, the third one. That is the position specifier. So there are two keywords that you can use as a position specifier. That is the first key, the first or the last. These are two keywords that are allowed. So this is an example of it. Set as $filter value, $ledger name, ledger entries. First is party ledger name. Please note, is party ledger name is the filter criteria, which is nothing but a system formula. This system formula says $let of group, $ledger name, group sundry debtors. So here we are trying to figure out, return the first ledger name from my ledger entries which falls under group sundry debtors. Num item returns the number of objects available in my current collection, like whether there are 10 ledgers, there are 20 ledgers, there are 40 ledgers, there are 500 vouchers. So num item is the function which will count how many objects are present within the collection and then it is returned. Filter count is used to get the total number of objects in a collection after the filter is applied. So when I say num items, it will only count the items and return it. Filter count will help me to return the count based on a filter criteria. For an example, I want the number of vouchers for party A. So I can say $filter count my collection name of type voucher. In my filter expression, I can validate whether the current whether my ledger name is equal to A. That's how the filter count works. Filter empty total. Again, it summarizes or it sums up all the expression which is of type amount yet based on the condition specified. Please note, you cannot specify the condition directly here. It has to be evaluating to a system formula. Similarly, we have filter QTY total. So these are the functions that are available: filter AMD total, filter QTY total. Now the set of data extraction and chaining in collections that we have collection field. This will only help us to extract a particular object value from my collection. So that is the collection field colon the value, which is a method or any expression that you need. Position number will be the index number of the object 1, 2, 3, 4. Again, we have two specific keywords here, first and last. So this is an example. $$ collection field colon $amount 1 all ledger entries. Now we come up to a very important concept of collection. Variables in collection. In any kind of simple collection, during the evaluation, whatever methods we provide, always evaluate on the basis of the current object context. Whereas in the cases of aggregated and summary collections, the evaluations do not take place. So whatever evaluations we want, there are three set of objects when we talk about a summary collection. There is a source object, there is a current object, and there is an aggregate object. So to perform any kind of computation based on the object it is available at, say, so there are some computations you wanted at the source object, or probably there's some computation you want at current object, or probably there's something that you want at that aggregate object. It is not possible to have or to perform any kind of computation. Hence, an inline variables have been introduced and can be declared at the collections, so that the variables helps us to do these kind of computations, for which three attributes have been introduced, that is the sourceware, computeware and filterware. So the values of these inline variables are evaluated before populating of the collection. So before the collection is flushed onto your interface, these variables perform their computation within the collection, and as per the utility it is applied. Starting with sourceware. So sourceware evaluates the value that you have specified based on the source object. Syntax is very simple. Sourceware, var name, that is the variable name, the data type that this variable will hold, and the value that you want this variable to hold. Simple. There's a simple example to it. Similarly, we have computeware. So computeware evaluates the value of expression based on the sub-object of the source. So whatever you have at the BOP is what computeware helps you to take care of. Again, the syntax is same: computeware, variable name, data type and formulae. And again, we have an example here. Then we have filterware. Filterware evaluates the value based on the objects available in the collection after the evaluation of the attributes of fetch and compute. So basically filterware gets can evaluate gets triggered after your fetch and compute. So whatever you require after this can be pushed into filterware. So let us take one simple example here. Let me show you the code that we have. So this is the code that we have. Just trying to pop up some data. Right? So we'll just go to the code. So this is our repeat line. We have one base collection which is of type voucher, filtered which is of type sales. Now how do I know what is there in this variable? So this is what we have done. Compute where in source logical is voucher type of sales or purchase. Only if the value is true, it gets pushed here and the filtration takes place. So this is how we have used compute where. So compute where is executed before filter where and acts either on my current context or my works on my current object. So current object is right now voucher. So $voucher type name is fetched from object voucher, which is identified here, and based on that values are pushed into this variable. Then we have a source where. In this source where we are trying to concatenate the voucher number with the voucher type name. So that's what we have done. Voucher number and voucher type name is what we have tried to concatenate, and we have walked to inventory entries. So my source is voucher. Now my current context is inventory entries. Compute where string. If src where, if this variable value contains 12, then return only $stock item name, else return the stock item name hyphen the variable. So here you will notice all these are concatenations because we do not have any voucher type number which is 12, or there is nothing which nor this contains 12. So we'll just pass one entry here which will showcase this sales number 12. This does not contain 12, right? So hence it is separated separately. Right? Then what we have done is, then the grouping is done on this resultant value. we would have given $stock item name, it would have directly grouped on my stock item name. So what we have done, we have grouped on my item name this computed value based on which build quantity is validated. Now what do we do? Wherever the build quantity is greater than 100, it is finally filtered out. So after the value is computed, we can validate whether the computed value is greater than 100 or not. If it is not greater than 100, filter it out. So the last voucher we passed is not greater than 100, because of which it is not reflecting in our data. So let's just change it here. You see here, now it is reflecting, right? So source collection, the collection name, source var helps us to act on the source collection, compute var helps us to act upon walked collection, that becomes my current object, filter var helps us to work on the aggregated values, and filter var can be further applied to filter, right? This is the same code explanation available here, where we have made use of filter var and source var. Generally, when we specify a filter at a collection, we can, we filter it as we externally filter it out, like $$ is sales colon $ voucher type name, or $$ is purchase colon $ voucher type name, which would also work. But in this case, what would happen is, after the collection is gathered, it will start filtering up my object voucher. Whereas in this scenario where we use the compute or the filter var, what will happen is, the values that we provide will start filtering up the collection as soon as it is gathered. So this is how the sequence goes. First it is source collection, source var, walk, compute var, by, aggregate compute, compute, filter var, and last we have filter. So no matter what sequence as a developer you write, this is the order of evaluation that the color collection will evaluate your attributes. So first will be source collection, then would be source var, then would be walk, compute var, by, compute, aggregate compute, filter var, and then the last thing that we will have is filter. This is the evaluation. After these three peculiar behaviors of variables, that we have the source var, the compute var, and the filter var, we have something called as parm var. Parm var is again a variable concept in collection. However, it is a context-free element available within the collection. So, although it is a variable, it is not related to the values available within the collection. It is related to the requester object contexts that is available for evaluating the values. Places where we could use $asterisk obj is where the parm var is utilized. But when we already had a function, why would we require a variable? Anyways, we did learn about a lot of functions that we have, and we learned about a requester object context, which was allowing us to evaluate values based on that context. Then why do we need a parm var? Basically, parm var is required when the values need to get evaluated onto the remote Tally. We need to evaluate certain values, and when we call the function again comes back to the server for evaluation. So to avoid these kind of request responses to be sent to the server is why the PalmWare was introduced. So we have just lined up a example here. A line groups and ledgers is repeating on a group collection. From within that, a part is exploded which displays list of ledgers of that collection. So the main part is repeating on groups, and we have an exploded part which repeats on repeats on ledgers. So there is one main line which repeats on groups. There is an exploded part which has a line and repeats on ledgers. So, and obviously when I explode my part here, I should get only those ledgers which are a part of this group. So what we have done is type collection child of palm led name. This $name evaluates in the context of list of groups in this context. Clear? So basically PalmWare helps us to evaluate a value and the context of the requester object context, not the current context. The other variables we saw it was within the collection. Here it is based on the requester object context. And that's all we have for advanced capabilities of collection. This is all what we have covered. We had a quick recap of the objects in collections, the basic ones. We did a data retrieval method formula syntax with relative object specifications. We learned about access name, object context switching functions, variables in source collection, the advanced capabilities, usage as table, the remote access capabilities, attribute walk EX, data source and functions to operate on collections. So this is a summarized slide of what we have gone through, the 2 videos of our objects and collections. Thank you very much. In case of any clarifications or queries that you have, please do write to us on support.tallydeveloper@tallysolutions.com.